Welcome back everyone, Patrick here, and moving on to another question dealing with triangles. So given triangle A that has the coordinate 8 and 2, the vertex A has a coordinate 8 and 2, the vertex B has a coordinate 11 and 13, and then C has a coordinate 2 and 6. And given that triangle, we have to, part A, show that it's an isosceles triangle, and then in part B, find the median from vertex B, and then in part C, find the altitude from vertex B. So we've gone through questions before where we're finding the median and the altitude of a triangle, but this is going to be a specific case that I wanted to go over. So let me just kind of show you in general the theorem we're going to be working with. And let's say in general, let's forget about this particular question, but let's say that we have a triangle A, B, and C. Like that. And then what we're going to assume is that this is an isosceles triangle, and in this particular drawing I'm going to make this side and this side be the same. Right? An isosceles triangle has two equal sides. So this side is the same. And as we've mentioned in a previous video, remember a median, if we draw a median from any of the vertices, it's always going to cut the area of a triangle in half. Well, in this particular case, what we're going to do is we're going to draw a median from the vertex where the two equal sides are meeting. So in this case, it's vertex B. That's not always going to happen in every triangle that you're dealing with. Maybe the two equal sides might be here. They might meet at vertex C. These are just all arbitrary letters that we're using, right? But in this particular case, the vertex that the two equal sides are meeting is at B. If you draw a vertex from, or if you draw rather a median from that vertex where the two equal sides are meeting, what is a median? Well, it's a line from the vertex to the midpoint of the opposite side. So the midpoint is going to be like over here, let's say. Okay, if you draw a median, and this is an isosceles triangle you're working with, well, what's going to happen is that the median from vertex B is going to equal or be the same as the altitude from B. Okay, another word you might see, instead of equal, you might see coincides. Right, the median from vertex B coincides with the altitude from vertex B. And remember, this B over here assumes that it's the vertex where the two equal sides of the isosceles triangle are meeting. Right, so that's what we're going to be doing here. We're basically going to be showing that the median and the altitude are the same from vertex B. And so we're letting you know that, and just we're kind of cheating here because I'm telling you ahead of time that basically AB and BC are going to be the same length. That's how we're going to verify that it's an isosceles triangle, but that's not always going to happen. Again, as I mentioned, you may get a triangle with coordinates and you may find that AC and then AB have the same lengths. And then you'd have to show that the median from A and then the altitude from A are the same. Okay, but because I kind of told you ahead of time that these two are going to equal, it's an isosceles triangle we're working with, we could tell that AB and BC are going to be the sides that are going to be equal in length, but we're still going to show all the work. We're still going to show the length of AC as well, not just the two equal sides. Okay, but going back to the general scenario, the median from B and the altitude from B are the same if it's an isosceles triangle and the vertex is where those two equal sides meet. Another thing that the median does is that the median from vertex B bisects or cuts in half angle B. So we already know that a median for any triangle, as I've gone through in a video before, cuts the area in half, right? For any triangle. It doesn't have to be an isosceles, could be a scalene, could be any triangle. It's going to cut the area in half. But as I mentioned in that video, that for other triangles, it doesn't necessarily cut this angle in half, right? These two angles aren't necessarily going to be equal for other triangles, but if you're dealing with an isosceles triangle, this median here, it's going to cut those two angles in half. Again, as long as the vertex you're dealing with are where those two equal sides are meeting. So for example, given this isosceles triangle, if we draw a median from vertex C, it's not going to cut that angle in half necessarily. It's got to be that vertex that you're working with. So those two angles are going to bisect. The median's going to bisect that large angle B into these two angles. They're going to be the same, right? So that's basically what is happening. That's the general theorem for an isosceles triangle, and when you're drawing a median from that vertex where those two equal sides are meeting. So that's what we're going to be doing here. And so let's label these points. So let's get into this specific triangle. So we got 8 and 2, we got 11 and 13, and then C is 2 and 6. Another thing I want to mention, this here is not to scale on a Cartesian plane. If you were to actually graph these points, so A would be at 8 and 2, so let's say that's like over here. And then B is going to be at 11 and 13, so this is 8, 11, let's say is like here, 13 is going to be like up here, so let's say that's like B. And then C is going to be at 2 and 6. This is just a rough drawing, so it's going to look, the triangle is going to look something like that, right? And then we're going to be finding this median and that altitude right there. Again, that's a rough drawing, but a more exact drawing than this one. But I'm going to stick to this drawing over here, but if you are required to graph it exactly, or if you want to take this question and graph it exactly on graph paper, you can do that as well. You can just take this and sort of, what are we doing here? We're kind of flipping the triangle and then rotating it a bit. But I'm going to stick to this triangle here as reference. So let's get into the calculations. So we have to show it's an isosceles triangle. How do we do that? We find the lengths of all three sides, and then if two lengths equal, then we know it's an isosceles. So let's first find the length of AB. Now the length formula in general, it's going to be what? The square root of x2 minus x1 squared plus y2 minus y1 squared. Right, so I'm going to let this be x1, y1. I'm going to let this be x2, y2. So we would have the square root of x2, 11 minus x1, that's going to be squared, plus y2 minus y1. And then that's going to be squared like that. 11 minus 8, 3, plus 13 minus 2 is 11, so we'd end up with 9 plus 121, which would give us the square root of 130. I'm going to leave it as an exact value. If you want to get the decimal, you could do that as well. I'm going to leave it like this. So this length ends up being root 130. Now, let's find the length of BC. Okay, so I'm going to let this stay as x2, y2. I'm going to let this be x1 and y1. So what we're going to be changing is this coordinate and that coordinate. So we're going to have 11 minus 2 and then 13 minus 6, like that. Right, we're finding the length of BC. So this would end up being what? 11 minus 2 is 9. 13 minus 6 is 7. That's going to be squared, so we're going to end up with 81 plus 49 like that. What's 81 plus 49? Well, it's 130. as well. So we end up with root 130. So as I mentioned, as expected, both of those sides are equal. And as promised, let's find that final side, AC, and then that side should be different, or else if it's the same as the other two sides, then it's going to be an equilateral triangle. But we're expecting it to be different, so I'm going to let this be x2, y2 over here. So we'd have the square root of x2, which is 2, minus x1, which is 8 squared, plus y2, 6 minus 2 squared. So we'd end up with what? Negative 6 squared plus 4 squared, which would give us 36 plus 16, which would give us 52, root 52. All right, so the length of AC ends up being root 52. Right, so those are the three lengths. Notice two of the lengths are the same, so we verified or we showed that the triangle we're working with is an isosceles triangle. Now what we're going to do is we're going to find the median and the altitude from vertex B. Okay, and as expected, they should end up being the same thing from that theorem that we talked about. So let's first find the median. So how do we find the median, the equation of the median? Well, we already have the coordinate of vertex B. Well, we need the midpoint over here. So let's find what that midpoint is. And what's the formula for a midpoint? Well, it's the sum of the x values divided by 2 plus the sum of the and then the y values divided by 2. Right? So we're finding the midpoint between these 2 points, between A and C. So these are already labeled as x1, y1, x2, y2. So we'd have 8 plus 2 divided by 2, right? And then 2 plus 6 divided by 2. This would be 10 over 2, which would give us 5. And then we'll have 8 divided by 2, which would give us 4, like that. Okay, so this midpoint here ends up being 5 and 4. And so now to find the equation of the median, we just have to find the equation of a line that's going through these 2 points. So let's write out the points over here. We got 11 and 13, and then 5 and 4. What's the equation of a line going through those midpoint, or those 2 points going to be? Well, first we have to find the slope. So I'll let this be x1, y1. Let this be x2, y2. So the slope in general is y2 minus y1 over x2 minus x1. Rise over run. So it would be 4 minus 13 over 5 minus 11. 4 minus 13 is negative 9. 5 minus 11 is negative 6. Negatives cancel out. Positive 9 over 6. What does that simplify to? 3 over 2. We could divide the numerator by 3, the denominator by 3. So this line here, okay, it's going to have a slope of 3 over 2. And then we have to find the corresponding b value. So we'd have y equals 3 over 2x plus b. We could plug in either point. I'm going to plug in this point. So we'll plug in 4 for y, and then we'll plug in 5 for x. So we'd end up with 4 equals, this is like over 1, multiplying these, the numerators, the denominators, we'd end up with 15 over 2 plus b. Bring the 15 over 2 over, so we'd have 4 minus 15 over 2 is equal to b. Change this to be a common denominator, so we'd have 8 over 2, which is the same as 4, minus 15 over 2 is equal to b. b would end up being negative 7 over 2, like that. So the equation of the median here ends up being y equals 3 over 2x, right, the slope, minus 7 over 2, the b value. right? That's the equation. And by the way, another way to go about it, if your teacher expects this or you prefer this way, I prefer this way, but you could also use this formula where you plug in the slope, plug in one of these coordinates for x1, y1, bring everything to one side except for the y value. You should end up with that same equation. And now in part C, what we're going to do is we're going to find the altitude from vertex B. And what I'm going to do is I'm going to just erase all of this just because there's lots going on. So let's draw a brand new triangle and let's just label the vertices here. So we'll have A, B, C. A is 8 and 2, B is 11 and 13, and then C is 2 and 6. Right, so let's just pretend that it's a brand new question and we're just finding the altitude from vertex B. Now, what is the altitude? Remember, it's the line from the vertex to the opposite side where that line is going to be perpendicular to that opposite side. So the angle right there between those two lines, between the altitude and that opposite side of vertex B, side AC, is going to be perpendicular, or the slopes are going to be negative reciprocals of one another. So what we first want to do is we want to find the slope of AC, right? If you remember the steps in finding the altitude. So we're first going to find the slope of AC, and that's going to be with the formula y2 minus y1 over x2 minus x1. So that's going to be step one. Then once we get that slope, we know what the slope of the altitude is going to be. It's going to be the negative reciprocal, or the perpendicular slope. So we're going to take that slope, we're going to find the perpendicular slope, and then we're going to have that slope, the perpendicular slope, and we're going to have the coordinate 11 and 13, and then we could find the equation of the line that has that slope and goes through that coordinate. So let's first find the slope of AC. So let's let this be x1, y1. Let this be x2, y2. So we would have 6 minus 2, right? y2 minus y1 over x2 minus x1. Okay, and you can label this x2, y2, this x1, y1, doesn't matter. The signs are going to end up being the same for the final slope. So this would be 6 minus 2, which is 4, and then 2 minus 8, which is negative 6. Notice we could divide the top and the bottom by 2, so it simplifies to negative 2 over 3. So the slope of AC is negative 2 over 3. So what's the perpendicular slope going to be? Well, it's going to be the negative reciprocal of this. So we're going to flip that and change the sign. So a negative to a positive, and then the 2 over 3 flips over to 3 over 2, as expected, right? That same slope for the median. Okay, and now it just becomes a question of where we have the slope of a line, and then we have a coordinate it's going through. How do we find the equation of that line? Let's actually use that other formula. Usually I'm using just y equals mx plus b, but let's switch it up in this case. So this is the x1, y1 that we're going to use. So we're going to have y minus y1, which is 13, and then we'll have 3 over 2, x minus x1, which is 11. Just want to be careful with my steps here, as I don't use this way too much. So what we do here is we expand, so we'd end up with 3 over 2x minus 3 over 2 times 11. Wow, there's so much algebra this way. I don't know why anyone uses this way, to be honest, but let's just go through it. So I'm going to continue this here. So we'd have y minus 13 equals 3 over 2x. Now this is like over 1. Negative 3 times 11 is negative 33. 2 times 1 is 2. And then we bring the negative 13 over. So we'd have y equals 3 over 2x minus 33 over 2 plus 13. When this comes over, it becomes a positive. This is over 1 to simplify these two, common denominator, right? So we'd end up with y equals 3 over 2x minus 33 over 2 plus 26 over 2. Negative 33 plus 26 gives us negative 7, and that's going to be over 2. And so as expected, notice the equation of the altitude is the same as the equation of the median. Right? And then if you didn't go through it this way, which I don't recommend you do, it's just a lot more algebra. If you just did it the y equals mx plus b way, right? You take y equals 3 over 2x plus b, and then you plug in 11 for x, plug in 13 for y, bring this over, you'd end up getting a b value of negative 7 over 2. Right? So whichever way you do it, the equation of the altitude is that. And as we mentioned, because this is an isosceles triangle and we're dealing with the median and the altitude from the vertex where those two equal sides are meeting, as expected, the median and the altitude coincide, or they are the same.